Thank you everyone for joining this webinar. Today we're going to be talking about some of the different applications of AI in FME, and we'll be showing a few examples that we've been working on to highlight the benefits of using FME within day-to-day workflows. This presentation was originally given at the One Spatial World Tour back in September, so hopefully a few of you on the call were there. For those of you who weren't in attendance, this will be completely new to you. Just to introduce myself, my name is Ian Fletcher. I'm a senior FME consultant at One Spatial. I'm a certified professional and a certified trainer. So to begin with, there are different levels of FME integration in different levels of AI integration into FME, and I hope to cover each of these throughout the presentation. Different levels of integration, different use cases. There are going to be different suitable applications for each person on the call here. The examples you've seen here, you will see here today, have been designed to show you some different types of applications that are possible. What they are not are completely out-of-the-box solutions. So to begin with, a brief introduction of AI. What is it for, in its context in FME, and more importantly, what is all the fuss about? So AI here is defined as a technology that allows we can think of it as a technology that allows a computer to think and imitate human behavior and human decisions. And that sounds simple enough in theory, but why would we want to use AI in the context of FME in the first place? Well, lots of different reasons. Some of these, hopefully, you will have already thought about, but broadly speaking, it gives us the power to automate manual tasks and to increase the efficiency of tasks that may otherwise be quite laborious. It's obviously led to many advances in different sectors of industry, such as medicine, automotive production, engineering, you name it. You've almost certainly interacted with an AI-driven chatbot when looking for customer support, and we've all seen AI-enhanced or AI-generated images online, on social media, etc. But of course, the reason why we're here today is where does FME fit into the conversation around AI? SAFE have recognised the potential for AI to revolutionise different parts of the workflow and have adapted some generative AI technology in a few different ways. We're only really going to be scratching the surface here of what's possible, but I want to, as I mentioned before, and I want to take a brief look at a few practical use cases where FME AI can make your life easier and can give you a few ideas of how you can use these applications to solve some of your data challenges, which may otherwise be quite tricky to automate in a completely hands-off solution. Always remember, however, when we're looking at these examples and when you're thinking about your own AI applications, AI is a model or a series of models. They are not perfect. Different AI techniques and different AI underlying models will give you different answers. Some of them will be appropriate for your use cases, some of them will not. So we're going to be starting with the basics and working up, and let's begin with AI Assist. Hopefully many of you will have seen this in action already, certainly if you are using FME 2023 or 2024. Although we describe, generally speaking, as a no-code authoring environment, in reality there are various commonly used transformers which leverage different, or allow us to leverage different scripting languages in order to complement our workflows and to query our data in different ways. And AI Assist has been developed to aid us in the production of these scripts or query writing. So let's take a closer look at that to begin with. So where can you find AI Assist? It's built into any transformer that involves building a regex, a SQL, or a Python script. All the obvious ones are here, so string replacers, string searchers, Python callers, creators, but don't forget you can also find it buried in things like feature readers and writers, and readers and writers, where you may wish to use queries to filter the incoming data or perform a SQL query after you've written data to a database. If you're running FME 2023 or a more recent version, you will already have AI Assist available to you. By default, it's switched on in FME options, but if you find that you cannot see it in any of the transformers listed earlier, go into Tools, FME Options, Workbench, and you may need to enable AI Assist in the tick box at the bottom. By default, the AI Assist functionality uses the Azure OpenAI service model and safe sorts out all the API keys and configurations for you. You can change this if it's not to your liking. Remember, however, if you use anything other than the default, you may incur costs against your own AI service provider's account. The default, however, is free. So let's try it out. I've got a demo here. I'm going to switch over to FME now. So what we have here is we have a database of parks in Vancouver. For some of you who have undertaken the FME Basics training course, this data may be familiar to you, but we have park data and a whole bunch of corresponding attributes associated with them. And we've got three different problems here we wish to solve with different scripting languages and different applications of AI Assist. So top one here, we want to do some regex to identify string length, where the park name string length is more than 10 characters long and must also include the word park. So conceptually, we are dividing what we consider to be a valid park name from an invalid one. And so we can take this, this natural language string here, we can go into the test filter, and as long as you have contains regex as the operator in a test condition, you will be able to open up the regex editor. You can, if you are already familiar with regex, write your code directly in this box here. You get some quick reference options here. But for those of you who are not familiar with regex, we've also got the AI Assist option at the bottom. Here we can paste in the code that we want to generate a regex script from. That code is sent to the API, and you can see it has returned the corresponding regex code that we're looking for. Click OK, click OK here, and now once more, and you can see now we will be dividing what we consider a valid park name from an invalid using a regex code which we've generated from within the AI. And give that a minute and it will pass through, albeit rather annoyingly slowly. It is getting there. There we go. So you can see we've got some valid park names where they're more than 10 characters long and have park in them, and then we have a bunch of invalid park names which are either missing or less than 10 characters long or do not include the word park. Notice also we've got a spelling mistake, a deliberate spelling mistake in the phrase that we've used, and AI Assist is perfectly capable of dealing with that spelling mistake, which is obviously very useful. So moving on now to SQL. Again, we're going to use an inline query here to extract just parks, the park name and the neighborhood name for parks where the tree count is greater than 50. And again, we can take the description here, go into our inline query, SQL query, go to the Open SQL editor, AI Assist at the bottom. We can paste in our our description here. Now this is slightly more complicated. If we generate a query without doing anything else, it will generate a SQL query, but it will not be valid because it does not know the schema of the database that you're trying to apply this query to. So you see that this neighborhood name, this neighborhoods table does not actually exist. To accurately reflect the database that you're passing this against, you need to send the database schema along with the query. Do that again. And if we apply that now, we will have a valid SQL query. So we run that and we will return just the park name and the neighborhood name for parks with a tree count of greater than 50. And see, you can see there is only 2 of them, so Vanier Park and Stanley Park. Finally, Python. So this is the one, in my experience, is the you have to be the most vigilant with. So again, we're going to create a Python function to create a new attribute is valid, which returns true for park name values that end in park and false for those who don't. So again, go into park, the Python caller AI assist. This is a little bit more complicated. So again, we can create a Python script. I'll look at the actions in a minute. In my experience, the Python scripts that it generates are the ones that you need to be a little bit more vigilant with. They do not necessarily always work in the exactly in the way that you intend. So it has, as we've seen, generated a Python script. However, there we go. However, it will not work because the Python script itself is not complete. So I think if we run this now, it will fail because it has failed to include an exception for where the park name is missing. And you can see this is going to fail in a minute, which it will do. There we go. Come on. My machine is a little bit slow. Apologies. There we go. So it's failed, and it's failed because the Python code that it has generated is not complete. It has failed to put an exception in here for where park name does not exist. So park name has to exist, and it has to end with park. So I believe if we now run that, it will now pass. And there we go. We have 80 parks, and we have our valid attribute here. So that is always worth being aware of. There are a few other things with the Python AI assist to be aware of. So you can supply it with a code and ask it to refine it. You can ask it to explain a code, and you can ask it to add comments. So, for example, if we ask it to explain the code we've just generated, you can see the explanation here does show you all the different components that it's identified. And this is a really nice way of actually learning about Python as well, because you get a description of the Python script that you are looking at. So yes, that is AI assist. So let me go back to the slides. So that is AI assist. We're moving up in a level of complexity now. And much like many of our favorite cloud applications and online services, many AI services that we are familiar with have been embedded into pre-built connectors and other FME transformers in order to create a library of out-of-the-box AI solutions. And we can directly access these from the transformer gallery. We're going to jump into a description of some of these now, and we'll see what we can do with these in a minute. So, as I mentioned, these are completely out of the box. They're already installed by default in FME 2024. There's lots of different AI connectors out there. Some of them you may be familiar with, some of them you may not be, but they all do sort of similar things. And we're going to try, in the next example, we're going to be building a workspace that deals with some of these. So each service has its own dedicated transformer, and we'll be looking at 3 of them here. So we've got the Azure Computer Vision Connector, the Google Vision Connector, and Amazon offering the Recognition Connector, amongst others. They all work in a very similar way. We create an account with the provider in question so that we can access their AI services. They provide us with a token, which you can enter into the token parameter of the connector. You may need to add a credit card behind the particular supplier's service. A lot of these are paid for services, so just be aware of that. You may already have an Azure account or a Microsoft account or Amazon account, for example, but the AI services tend to be behind a different layer of security, an additional layer of security. So it's always worth checking this when you're developing a workspace that is trying to use some of these connectors. So just going into a few of these in detail, the Azure Computer Vision connector will use Azure Cognitive Services account credentials to log in and will allow you to detect a number of features within an image, including objects, faces, and text. The Google Vision connector uses your Google Cloud account credentials to access the Google Vision client services. This works in a very similar way, but the model is also trained to detect specific documents as well as general text on a page. And finally, the Amazon Recognition Services connector will allow you to detect objects, faces, and text in images, and also describe image contents and faces. This model is also interestingly designed to detect faces that are including PPE equipment and also images that contain potentially adult material, which I think reflects some of the ways in which these models were initially built. So this is a demonstration pre-recorded, so you can see we have the three connectors in parallel here. We are supplying them each with the same image. The result is a JSON string which we're breaking down into a HTML table and supplying to an HTML writer. We have built this into a web app, which we will see in a minute. So we're going to send it, and we'll look at this, we'll see this in a minute. We're going to send it a picture of a pylon. This is a web app that we've created with this workspace in the background. We're going to upload the picture of the pylon. And notice here the differences in the results that the three models give. So give it once it's downloaded. So there's the original picture. See, Azure sees pylon and then a bunch of additional things. So text, outdoor object, cloud. Google sees cloud, sky, plants, and Amazon sees cable, power lines, electric transmission tower, and utility poles. So the different models recognize different components of an image to different levels of confidence. And this is interesting because it does suggest that depending on what you want to extract from an image, different models will be more appropriate than others. So, for example, if you were looking for a model that would allow you to identify infrastructure and I know power network, power cables, things like that, you would suggest that the Amazon model is more appropriate because it did a better job of actually identifying what we need. And did not necessarily return things that we weren't concerned about, like cloud, sky, and plant. But if you were looking to recognize images that had took it into account things in the background, so the background of the image, then maybe the Google or the Azure services would be more appropriate. So, as we can see here, we can derive or produce additional information based either on images, keywords, text sentiments, document recognition, text within a document, etc. But the beauty of using this within FME is once we've got this information, it is now part of one of our FME workflows, and we can do with the information that is returned from the AI whatever we want to by building in additional FME workflows to handle this. So we may want to perform, I know, sentiment analysis against business reviews. We may wish to catalog automatically catalog incoming images to a file server. They may need sorting into folders based on their contents and tagging appropriately. Maybe we want to analyze the contents of results based in different parts of the country. Lots of different applications, lots of different ways in which we can combine AI connectors into different FME workflows. One thing to bear in mind though, as we saw in that example, different services will give you different answers. And you need to be aware of what the different models are, what the specialties of the different models are. Ultimately, if you want more control over the results, you may wish to use a service which allows you to train your own model. The models that we've seen here are using out-of-the-box pre-trained models by the different service providers, so they are very generic in their application. But you can train your own model using services such as Olama to train and run a large language model locally. As we've seen in our examples, however, perfect, so set your expectations accordingly and build in appropriate levels of validation into whatever workflow you're designing. So the transformers we've been looking at are all pretty straightforward. They're standard API calls to these generative AI services built into connectors that we know and love and have used with different cloud applications for a number of years. What happens, however, if we want to do something a little bit more complex, a little bit less out of the box? Well, for that, we've always got the good old HTTP caller, which in this case we can consider to be an AI transformer because of its capabilities of calling different API endpoints and returning results from different services accordingly. So let's take a look at this. So we have, in this example here, we've decided to be a bit lazy, and instead of manually reviewing and typing up our expenses, we want to construct a workspace that reads and interprets them for us and gives us a nice spreadsheet of our results that we can submit directly to our finance department. Here's some of the receipts. You can see they're of varying quality. Some of them, so lots of different receipts, different languages, different colors. Some are crumpled, some are PDFs, some are in a Word document. You get the point here. Lots of different formats, lots of different qualities. What we'd like to do, however, is use an AI model that's been specifically trained to recognize receipts and to extract the various components from them, such as date, price, VAT, vendor, for example. For that, we're going to be using the AI services provided by Azure for this, and we can use we can go to the Azure documentation and we can see some of the pre-built models that we can hook into, and you can see there is indeed a receipt model. The receipt model will recognize different aspects of a receipt, not just recognizing the text, but what that text is representing. So is this the vendor address? Is this a VAT number? Is this a price, for example? And it can create a tabular output accordingly. This does not have a connector, so we required to use the HTTP caller in order to use this. So this is the workspace that is running that is allowing us to run and manage the results from the receipt recognizer. And there's a few components of this workspace which are worth mentioning. The start and end in yellow are pretty much formatting steps. So just orchestrating the data going into the API and breaking it down into a usable a table once the results have been returned. In red, we see the image of a receipt being converted into binary, because it's a binary value which the API requires, and then we're posting it to the HTTP caller, the AI service. The black box here is interesting. We're running a looping custom transformer that allows us to regularly poll the API using a get command in order to ensure that we've got every single result back before we return the table to the end user. So this is again another pre-recorded demo. So we have a folder of receipts, different qualities, different formats. Again, very typical kind of expenses issue here. Very onerous, very manual. We're going to take these expenses. We're going to pop them into the web app that we've created accordingly. Those receipts are being uploaded, and once we run it, they are being converted into binary. They are being run through the API, and we will return a spreadsheet. That spreadsheet has different tabs here, so breaking down all the different fields, an itemized list of expenses, and then the line-by-line items. So again, we extracted more information here than we need, but this does allow you to take a chaotic bunch of receipts and break it down into something tabular and ordered, and potentially something that you could submit automatically to a financing system if required. It's not, and again, the point of here and the power of this example, it's not just text recognition. It's AI-driven recognition of components of a document, a specific document, in this case, a receipt. So given a large, the model's been trained on a large number of receipts, and it's been trained to find certain textual, numerical, and date-based elements based on their position on the image and their proximity to other elements. And being now integrated into AME, into FME, sorry, we can use this information to submit to another system or download to a format. So we've downloaded to Excel in this case, but you can very well imagine a scenario where you take this tabular data and submit it straight to Salesforce or I know Monday or some other financing system using another API call. Going further, we could use FME to recognize the different types of receipts or the different elements on the receipt and use this information to drive, for example, who is CC'd into the email for specific approval. Lots of different ways you can go with this. So in summary, AI is powerful and is just another tool in our arsenal for building powerful FME workflows and automations. On its own, it's a source of interest, but it can help shape our understanding and give us further information and insight on the data that we are passing into and out of our FME workflows. AI comes into its own when it's orchestrated within an FME workspace. So it's all very well having these AI solutions, but unless you can do something with the data once it's returned, it can be equally overwhelming to deal with. So you can use FME workspaces to build in a way of managing the returned results as we've demonstrated here. And yeah, that's the end of the three little demonstrations I've prepared for you.